Hey guys, so today we are doing our project on the Natural History Museum, and you may wonder, what does this have to relate to anything we've learned in class? Well, my dear friends, I will now present to you my classmates who will take us through this journey, and as we learn how all this relates to geology.
Hey, my name is David. We are the German mineral in the Natural History Museum. What are minerals and how do we identify them? By definition, a mineral is an inorganic solid that possesses an orderly crystalline structure and can be identified by its unique chemical composition. On the topic of identifying minerals, color is probably one of the first things that comes to mind. But in reality, the same mineral can come in an array of different colors, like quartz for example. The two most effective ways of identifying minerals are its hardness and luster. Hardness is often mistaken for toughness, which isn't exactly the case. Hardness has little to do to a mineral's resistance to breaking. Instead, it's a scale of 1 to 10 that measures a mineral's ability to scratch other materials. Just because diamond is the hardest thing on our planet does not mean it's the most durable. Glass is commonly used to test this, but other materials may be used as well. The second factor is luster. Luster refers to the way that light reflects off of a mineral. A metallic luster refers to a mineral that has a gold or silver shine to it, like copper. A non-metallic luster refers to a crystal that may be opaque, translucent, or transparent, like calcite. Another important property that minerals possess are cleavage, which relates to how a mineral will break. Some minerals are formed in planes. We may use this knowledge to predict what shapes the mineral will fracture into, otherwise known as predictable breakage, while others simply shatter into random pieces. With all that being said, color isn't completely useless when identifying minerals. For example, the color that a mineral is when powdered, or its streak, can factor into identification. To test this aspect, the mineral is rubbed against a streak plate, and it is recorded whether it leaves a colored streak. For example, hematite might scratch red, a white streak, like sulfur, or no streak at all, like quartz. Overall, we use these techniques to distinguish between over 4,000 different minerals, with different origins and properties, like for example, silicates, the most common type due to the large abundance of silicates and oxygen that naturally occur throughout the planet, and non-silicates, that are less common but serve a crucial part in our everyday life, like copper, lead, and iron.
Hey guys, my name is Malcolm Fisher, and today we're going to be taking a look at the Becoming Los Angeles exhibit. To understand the history of Los Angeles is to understand a geographical substance that was vital to the region's economic and population booms. This substance is known as oil shale. So what is oil shale? Oil shale is a type of sedimentary rock that forms from fossilized remains under intense pressure and heat. As a precursor to oil and natural gas, oil shale over time releases what is known as a liquid called shale oil. This is the substance that fueled the oil boom in Los Angeles in the 1920s through to the 1930s, as oil industries rushed to extract all obtainable shale oil within the LA region. Although extremely profitable, the industry came with an abundance of hazards to those who lived and worked within these oil fields. Now, where did this oil shale come from that caused such an abundance to form in the Los Angeles region? For a period of over 90 million years, Los Angeles existed as an underwater shallows, rich in marine life. As the area transitioned geographically into an above-ground subtropical climate, a massive amount of fossilized remains were left over from its former existence as an underwater climate. These fossils, when compacted with millions of years of sediment, eventually formed into what we know as oil shale. Fast forwarding to the early 20th century, we can see the LA region generating approximately 25% of the world's oil production, which in turn fueled the economic and real estate growth during the 1920s. Between 1920 and 1930, we can see the Los Angeles population more than double from 600,000 to over 1.2 million. This boom formed the basis of the California economic power that we have to this day. The legacy of the LA oil industry is being felt to this day through economic wealth at the cost of climate change, pollution, and fires.
Today, my portion will be about the dinosaur home. So come with me and find out what's inside. Now, you might be asking yourself, why are fossils important to geologists? You probably didn't ask that, but I'm gonna answer anyways. They're one of the most important tools in understanding the age of the Earth. Through the process of evolution, different kinds of fossils occur in rocks of different ages, enabling geologists to use fossils to understand the geological history. They also use fossils as a means of establishing a geologic timescale with the timing of the emergence and disappearance of widespread species from the fossil record. A geologic timescale is a representation of time based on the rock record of the Earth. It basically helps us understand how Earth evolved over the millions and millions of years. How do we determine the age of the fossils? When a paleontologist finds a fossil, they determine the approximate age of the fossil by the area surrounding it with the help of a geologist. Because fossils are usually found in sedimentary rock layer, a geologist can date them by examining the minerals above or below the sedimentary rock. Although they cannot determine the exact age of the fossil, they can determine the time period it has came from. Hint, the geological timescale. Fossils and the ocean. Now, I'm sure we all have been to the beach or the river or the lake or the ocean before. I'm sure we're all aware that the ocean flooring is much different than the land floor. One of the reasons why they're different is because of the minerals. Let's use limestone as an example. Limestones are composed of calcium carbonate and mostly all formed from the accumulation of oceanic organisms. This is where fossils come into play. Basically, when small marine organisms die, their shells and skeleton build up on the ocean floor and basically form a sedimentary rock, aka a fossil. The ocean also has the best chance of preserving a fossil since they're mostly safe from scavengers, acid rains, or clashing with other minerals and rocks and possibly breaking.
Thanks for watching, guys. I hope you enjoyed our presentation.
Woo!
Bye.
Bye-bye.